Hey guys, I went a little over 15 minutes on the last one, so this is still segment 3, but this is part B of unit 4. Just a couple of slides, it won't take long at all. But I really wanted you guys to realize that every greenhouse gas is not the same as another greenhouse gas. Now, we know greenhouse gases are unique from other gases in that they have the characteristic of absorbing energy, taking that energy in, and then converting it back out as heat energy out to all directions. But some of those directions face it down toward the planet, down to the ground. And so they act essentially like a blanket in our atmosphere. But, so not every gas is a greenhouse gas. And we listed the ones that are earlier in the notes in the last part A. So this section, you do not need to know the exact values, but you do need to know the fact that water vapor, for example, is providing 95% of our greenhouse effect. And I also need to mention here that the greenhouse effect is not all bad. It's what allows us to have less extreme temperature changes between our day and our night. You know, we might have 10, 15, maybe at the most 20-degree differences between our day and our night, rather than a 150-degree difference between our day and our night. You know, having a greenhouse effect, it acts as a cushion of sorts, allowing the fluctuation of temperature to not be as great. So anyway, water vapor, 95% of the greenhouse effect is from water vapor. Water vapor, which we told, you know, there's no real anthropogenic or natural, so I mean, it's the water cycle. So we have water vapor in the air all the time. So we're only really talking about 5% of the greenhouse effect when we're talking about the rest of the greenhouse gases. So of that 5%, you know, that's just crazy. Anyway, 5% is due to all the other GHGs. And within that 5%, we have carbon dioxide making up most at 3.6%, methane at a 0.36%, NOx at a 0.95%, and then CFCs and others make up a measly 0.07%. So when you're looking at the breakdown of the percentages, CO2 makes up the most aside from water vapor. Now, the questions. Can humans control water vapor? Think about it. We cannot. I mean, with a warm air can hold more water vapor than cold air. So this whole greenhouse global warming situation is actually making more water vapor stay in the air rather than condensing out and coming out in different form. And we use water, yes we do, but if we were here, if we were not on the planet, we would still have water vapor going into the atmosphere. So really we cannot control. So what can we control? We can control all of the anthropogenic sources of all of the rest of the GHGs. So oftentimes, you guys, you'll see that water vapor is left off some of the statistics because there's nothing that we can do about water vapor. But we can control some of these sources of these GHGs. All right, some GHGs are actually more powerful than others. So not only do they exist in different amounts, but they actually absorb differently. One little dinky methane is equal to 21 carbon dioxides. Okay, so you could have one methane floating in a pocket of air, and it would absorb just the same amount of energy as 21 carbon dioxides floating in the air. So which is stronger? Methane is stronger. One surface ozone, that's on the surface, not in the stratosphere, is equal to 100 carbon dioxides. So 100 times more powerful at absorbing energy and converting it to heat, to more heat than carbon dioxide. That's astounding. One NOx is equal to 310 carbon dioxides. Very different, very, very powerful. And then the most powerful is the CFC. One of those is equal to 6,650 carbon dioxide. That's insane. But when we go back to this original over here, how come CFCs only make up 0.07%? That's the question, like, and others. If it's so powerful, why is it such a small percentage? And if CO2 is so weak, I mean, if all these other molecules are stronger, then why does CO2 make up 3.6% of our 5%? Why is that? So the reason is because CFCs, there's not very many of them out there, thank goodness. Okay? So they must exist in such small amounts that their impact is much smaller than carbon dioxide, which if carbon dioxide is so weak, yet it makes up 3.6% of the warming, that must mean that there's a lot of carbon dioxide in the atmosphere in comparison to the others. So which GHG is the strongest? CFCs. Which GHG is the weakest? Carbon dioxide. And if carbon dioxide is the weakest, then why is it responsible for 3? I mean, that's what we just covered. So it must exist in a high number. And that's it, you guys. This is the end.